So today we're going to finish up section 1.1, looking at how we can solve equations with multiplying and dividing. What are the two operations that we learned on Monday that we can use to solve equations? Remember, what were the two operations we used to solve all the problems we did on Monday? Yep. I know we talked about distributive. So we talked about evaluating, but when I say operation, what's an operation in math? Yes.
Subtraction and addition.
Yep. So add, subtract, multiply, or divide. And the two that we learned about on Monday were adding a number to both sides or subtracting a number from both sides. Today we're going to look at multiplying and dividing. Okay, so with adding and subtracting, you can add or subtract any number that you want to both sides. With multiplying and dividing, that's not true. There is one number that you're not allowed to divide both sides by. And we'll talk about what that number is. Same with multiplying. There is one number you are not allowed to multiply both sides by. Any other number you want is fine, except for the one I'm thinking. And I'll show you what that is. So this was actually Monday. There is no spot on your guided notes to write that. Just a reminder of what we've already done. We used addition, and we used subtraction. And it was only one step. So you had a problem like this. There's just one step to solve it. Alex, can you remind us, how would we solve that one?
How would we solve that one? You take 5 minus 3, so you get your answer.
So can you tell me, what did you do to both sides?
I do both sides.
Yeah, what would you do on the left side and the right side to get x by itself?
So if you minus 3.
Minus 3. So one thing I noticed on the homework, some people aren't showing that step, okay, of minusing on both sides. Just make sure you show me what you did. Otherwise, if you just put x equals 2, I don't know how you got that. I mean, I don't know. So just make sure you show me that one step. Okay. So, addition and subtraction. So today we're going to solve equations using multiplication and division. Again, there's no spot on your guided notes to write that. Just kind of reminding you what we're going to do today. Alright, so we talked about adding a number to both sides, subtracting a number to both sides. This, again, you guys just have to look at this. I just want you to read it. You don't have to write this part down. The multiplication property says that you can multiply both sides of an equation by the same number, except 0. Right, so you can multiply by any number you want on both sides of an equation, except the number 0. What would happen if you multiplied both sides by 0? Like, let's say you had something like 8x equals 16. If you multiplied the left-hand side by 0, what would happen to it? Caleb?
So, can you repeat the question, please?
If you multiplied the left-hand side by 0, what would happen to it?
You wouldn't get the answer, so it equals 0.
So the left-hand side would turn into 0. Now, if you multiplied the right-hand side by 0, what would that turn into? Yep.
0.
That would also turn into 0, which now that doesn't even make sense. If you multiply both sides by 0, essentially what you've just done is you wiped out the whole problem. Now you don't have anything left to solve. All right? So we need to learn, well, we just need to remember you can't multiply both sides by 0. All right. So this is the first thing on your guided notes that you have to write down. It says at the top, if the coefficient of the variable is a fraction. Can someone remind me, what's the coefficient again? Remember? Yeah. The number in front of the variable. So in this case, we would say the coefficient here is 8. But if you have a coefficient in front of a variable, that's a fraction. The way you're going to solve it is you're going to multiply it. And you're going to multiply both sides by the reciprocal. So an example problem where you would see something like this. This is an example that would have to use what I just said. If the coefficient of the variable is a fraction, in this case it is, then to solve it, we're going to end up multiplying both sides by the reciprocal of the fraction. Right, so I just want to make sure we remember from a couple days ago what a reciprocal is. So we're going to make a table, and we're going to just write a few numbers in it and make sure we remember how to find the reciprocal. So on your guided notes, you guys have a table right below the part you just wrote. It says fraction on the left, it says reciprocal on the right. And what we're going to do is see if we can fill in some numbers for a fraction, and then I want you to tell me the reciprocal. Megan, what does it mean to find the reciprocal?
Flip the fraction.
Right, it means to flip it. So can you tell me what the reciprocal would be for 5 over 2?
2/5.
2/5. So if 5 over 2 was the number in front of the variable, when we try to solve this problem, it would involve using 2/5. Okay. How about if we had -3/4? If that was in front of a variable and we had to solve, what number are we going to end up using when we solve it? Yep.
-4/3.
You're going to use -4/3. Yep. Very good. And that's an A in the bottom. 2 over A. It doesn't matter if it's an A. You still do the same thing to find the reciprocal. What would be the reciprocal of 2 over A? Yep, Dorn.
A over 2.
A over 2. All right, we got one more. B over C. Yeah, let's see. What would be the reciprocal of B over C? C over B. We just flip it. If you take a number that was positive and you flip it, is it still positive? What do you think? Yeah. Yeah. If you take a number that was negative and you flip it, it's still negative. So flipping something doesn't change positive and negative. It stays the same. Flipping something is exactly what I just said. It takes the numbers and it flips them. Any question on that? So again, the reciprocal is going to be used when you have to solve an equation and there is a fraction in front of the variable. If there's no fraction, well, we'll talk about that after. But we're going to try a couple with fractions. All right, so here's the steps that we're going to use to solve our examples. So on that first line, when you have a circle, first thing you want to do is find the number with the variable attached. It could be a fraction, like we just mentioned. So find the number with the variable attached. So just to show you what I mean by that, in this case, that is the number that's attached to the variable. 2/3 is attached to the 1. So that's the first thing. Find the number that's attached to the variable. If the number that's attached to the variable is a fraction, we're going to multiply, and multiplying is fine. We just said you can multiply as long as you do it on both sides. And the way you have to solve it is multiply both sides by the reciprocal. Multiply both sides by the reciprocal. So there's really two types of problems where you have to multiply. I'm going to show you, we're not going to do it yet, but I'm going to show you an example of each type. Let's make that a number. So that's an example of, we're not going to do that one, but that's an example of a problem where you would have to multiply. And it's this case. There's a fraction attached to the x. So we multiply both sides by the reciprocal. The other case you can have, where you have to multiply on both sides, is if you see something like this. Let's say you had, I don't have a ton of space here, but let's say we had x divided by 5 equals 4. That's the other type of problem where you do have to multiply to get x by itself. So if you divide by a number, we have to multiply, or if the number in front is a fraction. Those are the two times. So these two rules are going to cover the first half of everything we do. Those are the times when you multiply both sides by a number. What's the other operation that I said we were going to look at today? Besides multiplying? Yep, dividing. A dividing problem would be when you have something like this. Okay, so you might look at it and say, well, wait, you said when there's a number attached to the letter, we always multiply it. If it's a fraction attached to the letter, we multiply. If it's a whole number, okay, like that, to solve this kind of problem, you have to divide. Okay, so that's going to cover the second part of what we do. And that's this rule right here. So if you have a whole number or a decimal attached to the variable, we're going to divide both sides of the equation by what's attached to the variable. If it's a decimal, we're probably going to use a calculator because it can be kind of hard to divide by a decimal. So again, we'll use a calculator to figure that out. Now, once you write down what you're going to do, then you actually have to do it. Right? So either use your calculator to simplify the problem, or if you can do it in your head, you can do it that way. So after you figure out whether you should multiply or divide, your last step is to simplify both sides by doing arithmetic. So that's a simplify both sides of the equal sign. Now, what should we always do to make sure we got the answer right? What did I say we could do? And some of you did this and you found that you made a mistake, so that was good because then we went back and we fixed it. Huh?
Check.
Yeah, you should always check it. Now I put if necessary because it may not ask you to always check it. If the directions don't say to check it, then you don't have to. Would I recommend it if you have time? Yes, because it's always better for you to check your answer and see you got it wrong before I check it. Especially on a test. Right? So as far as like rules and steps, those are the only steps we have to know for today. You have to know when to multiply, and you have to know when to divide. Okay? And as I go through and I call on people, if you get stuck, go back, look at your guided notes, and look up the rule for when you multiply or when you divide. Okay. Does everybody have those steps? Yes. You good? Anyone else need to copy anything down? I try to leave enough room on the guided notes for you to write it in. You might not always have enough space, so if you have to write it, off to the side or something, you can always do that. All right, so let's try an example. So this is example 1A. It's off to the side on your guided notes, to the right of all the lines where you just wrote stuff. Okay, so first thing I'll do is I'm going to put the problem up, and then I just want to figure out, is this a multiply problem, or is this going to be a divide problem when we try to solve? It says x divided by 4 equals -7. So go back up and look at what's highlighted in yellow. And which one, if I numbered these like different cases, case 1, 2, and 3, does anybody see which case this one is? X divided by 4 equals -7. Is it the first one, second one, or third one? Lexi? The first one. So that means you have a fraction attached to the variable. So that means it looks like this one. No, we don't have a fraction. By attached, I mean next to. Right? There's no fraction next to the variable in this one. Yeah, Maya?
2.
Yeah, it's the second one. A variable is being divided by a number. So what are we supposed to do to solve when you have a variable divided by a number? Are we supposed to multiply? Or are we supposed to divide? Yeah.
Multiply both sides by the number.
Yeah, we're going to multiply both sides by the number. So, Brady, can you tell me, what am I dividing by here?
4.
4. So 4, when I say the number right here, in our case, the number is 4. So we have a variable divided by 4. So we're going to multiply both sides by 4. So let's multiply both sides by 4. So times 4 times 4. Now, look at what you have right here. You have 4 times something divided by 4. Those cancel out. Because imagine if I said to you, all right, I'm going to give you 4 times the amount of money, and then I'm going to take that and divide it by 4. Well, if I do that, you're right back where you started, because I gave you 4 times as much, but then I divided it by 4, so it reset it back to the beginning. So these cancel out. On the left-hand side, all we have now, Natalie, what's on the left now? Just x equals, and on the right-hand side, we need to simplify -7 times 4. So Emily, what's -7 times 4? Good. So if you get stuck, the first thing is say, okay, it's a negative times a positive. What did we say a negative times a positive is? A negative. And then 7 times 4. Again, if you need a calculator, I'll have some. Or you saw the one in Edulastic, you can use that one as well. So we have to actually write down the answer. -28. All right. Finnegan, are we done this problem? No. What else do we have to do that we didn't do that?
Check.
Yeah, we have to check it. We don't always have to, but this one did say to check it, so we'll check it. Sophie, how do I check if -28 is the correct answer? Yeah, we're going to replace x with -28. So when we check it, we've got -28 divided by 4 equals -7. And again, I put a question mark there because I don't know if that's right. I hope it's right. But that's the whole point. We're going to check it. So now we just have to see what's -28 divided by 4. We can use our calculator. -28 divided by 4. And that gives me -7 on the left. I have -7 on the right. So does that mean our answer is correct? Or does that mean we got it wrong? Yep. It's correct. Yeah, we got it right. When you check it, the idea is you have the same number on both sides. -7, -7. If you don't get the same number on both sides, then something's not right. Okay. Any question on that one? Okay, so that's an example of multiplying on both sides. Okay, example 1b. First, I wanted together just identify what case this one is, and then I'm going to give you guys a couple minutes on your own to try to solve. So I can try to put the cases back up. It's going to look a little bit small. But example 1b, 2/3 y equals 6. Is that case 1, 2, or case 3? Which one, Abby? That's case 1. If a fraction is attached to a variable, yes, we have a fraction right next to a variable. So that's case 1. It says multiply both sides by the reciprocal. All right, so take a couple minutes and see if you can solve that problem on your own. And if you get stuck, I'll walk around and try to give you a hint. Okay? All right, so we said this is the case where you've got a number attached to a variable. So we're going to multiply both sides. Can anybody remind me, what am I going to multiply both sides by? Yeah, Dorian?
The reciprocal.
The reciprocal, which in this case is what? 3 over 2. And now we're going to do the same thing on this side. Times 3 over 2. Now, the 6 wasn't a fraction. But if you wanted to make it one, because you have another fraction that's next to it, how can you make 6 a fraction? Yeah? You can put 6 over 1. Now, let's simplify what we have. When you want to multiply fractions, one way to do it is to go straight across. 3 times 2 gives me how much? If I multiply the two numbers in the top. Yeah?
6.
6 divided by 2 times 3. What does that give me in the bottom? Yep. 6. That's the whole point of multiplying by a reciprocal, because it will always give you the same thing in the top and in the bottom. And 6 divided by 6 turns into what number? Yep. 1. So we can basically just cross those out. That will always happen when you multiply by the reciprocal. Now on this side, do the same thing and see what you get. 6 times 3 goes in the top. Yep, Case. 18. And 1 times 2 goes in the bottom. About 80. 1 times 2. 2. So my final answer, 18 divided by 2 gives me, Sean? 9. Very good. And that's it. Since we just checked the last one, I'm not going to check this one. So again, on the homework, please make sure you show me something besides just the part I circled. Yes, that's the answer, but I need to see what you did to get it. All right? So that way I know you know how to actually do it. Okay? Okay, so any questions on that type? That's when you multiply both sides by a number. Yeah. Oh, yeah, you can sign up. So the last property we're going to look at today is division. The division, and this part, you guys don't have to write this down. I just want you to look at it. It says you are allowed to divide both sides of an equation by the same number, except what number can't you divide by? It's the same number you can't multiply by. Yeah, 0. Yeah, you can't divide by 0. Okay? Any other number besides that is okay. And we know you have to divide when you have case 3. If you have a whole number or a decimal attached to the variable. Now, if it's a whole number, we're probably going to be able to do it without a calculator. If it's a decimal, probably going to need a calculator. All right, so for case 3, we're looking for problems like this. Say something like 10 equals 2x. That's a case where you have a whole number attached to the variable. That's not a fraction. Or maybe you have something like this. 18 equals 3.6x. Both of those cases would involve division. And what you divide by is what is attached to the variable. So you end up dividing both sides by the number attached to the variable. All right, so let's try example 2a. It says 18 equals 3x. So let's look at our cases. And can somebody tell me 18 equals 3x? Is that case 1, 2, or 3? Which one is that? 18 equals 3x. Yeah, that's the third one. That's where you have a whole number. Remember, a whole number is just the number that doesn't have a decimal. Okay? We have a whole number attached to the variable. So, what math operation do we use to solve this? It's either we're going to try multiplication or we're going to try division. Good? Yep, we're going to divide. And what do we divide by? Yeah, divide by the number that's attached to the letter. Divide by 3. Divide by 3. Okay, Joe, when I do 3 divided by 3, what's 3 divided by 3? Think about if you had $3 and you give it to 3 people, everyone gets how much?
1.
1. So because that comes out to 1, we can cancel it out. And on the right-hand side, all we have is an x. Now the left-hand side, we can use a calculator if we need it. If we can figure it out without it, that's good. Anyone think they can tell me 18 divided by 3? How much, Abby? 6. There we go. So x equals 6. And Micah, am I done this problem? No, because I didn't do everything they asked me to do. What didn't I do?
You didn't replace
Right, we didn't replace x with 6. We didn't check it. So 18, this is to check it. 18 equals 3 times, and fill in 6 for x. Why did I put the 6 in parentheses? We talked a little about this on the first day. I didn't have to use parentheses. I could have done something else, but I had to do something. Yeah?
Because if you just multiply itself, it looks like 36, and parentheses shows that you're multiplying.
Right. We have to show that we're multiplying. We don't want it to look like 36. Okay? So we leave it like that. Put a question mark there, because that's what we're going to find out. 18 equals, if I check 3 times 6 on my calculator, perfect. That does work. So we know we got it. Any question on that? Oh, so that was 2A. Let's look at 2B. Right there. Now, this one you might not be able to do without a calculator. So do as much as you can up to the step where you would need a calculator, and then we can do that step together. It says 8.5x equals 40. Is that the same case as the last problem? Or is that a different case? What do you think, Sean? It's the same case, right? It's where you have a decimal attached to the variable. So it's the same case. So, Mia, since it's the same case, what operation am I going to use to solve it? We're going to use division. And Alex, can you tell me what I would divide both sides by to get x by itself? 8.5. 8.5 divided by 8.5 cancels out. We get x equals, now we're probably going to need a calculator for that. Okay, so 40 divided by 8.5. Let's see. 40 divided by 8.5. And Abby, can you just shut that one? There. So we get 4 point, I don't know if I can put that over here for you to see it. No. It says 4.7, okay, roughly. Usually on a problem like this, I would give you, like, say, round to 2 decimal places or 3. Let's write some of them down. 70588. If I said to round that number to 1 decimal place, what would the answer be? Yeah?
4.7.
4.7. What if I said to round to 2 decimal places? What would the answer be? Yeah? 4.71. Good job. So remember, when you have to round, you always have to look at the place after it, and if it's a 5 or higher, we round up. So in this case, 7.1. And technically I should go like this, because that's not the exact answer for x. That's roughly the answer. It means we rounded the answer off. Okay. Okay, we're getting towards the end. So the last blank we have to fill in on the guided notes is what the word of means. Anyone have a guess what of means in math? Yep. It means multiplication. So like if I said to you, what is 1/2 of 10? what's half of 10? You'd say, okay, well, figure that out. Half times 10. That's how you figure out half of 10. So the word of is used to mean multiply. Just like if I said to you, what's 2/3 of 12? 2/3 of 12. You take 2/3 and you times by 12. So now, let's finish up with example 3. Do you guys already have the word problem itself printed? And you got notes? Okay, so you don't have to copy that now. All we have to do is figure out how to solve it. So it says in 2012, Usain Bolt won a 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed. Now, the reason it says average speed is because, think about like if you start running. When you start, you're not moving at all. And then as you start moving, you get faster and faster and faster and faster till finally maybe you hit your maximum speed. And you can stay at that maximum speed for a little bit. And then if you kept running, you'd probably slow down again. So his speed might be changing a little, but we're just going to find his average speed. All right, now, to do this, there is a formula that you need to know, all right? There's 3 things in this problem. 200 meters. What does that represent? 200 meters would represent, yep.
The distance that he's traveling.
That's a distance. Yes. So our formula is going to have distance in it. What does this represent? 19.32. Yeah?
The time.
That's a time. That's how long it took him to go that distance. So our formula is going to have a t in it for time. So this is distance. This is time. And what are we solving for in this problem? What do they want us to figure out? The average what? Speed. That's the third thing. A lot of times they call speed the rate. The rate of, like your rate of speed is how fast you're going. So this is the speed. Okay, if you didn't know that formula, that's okay. You wouldn't necessarily know that. But now you do. Okay, that's called the distance. Well, it's the distance, speed, and time formula. So what we do now is we fill in everything that we know. We're going to know 2 out of 3 of those letters, and we're going to solve for the third one. Let's start from left to right. Do we know the distance in this problem? Lexi? Yep, 200 meters. So 200 equals, do we know the speed in this problem? That's the next variable. No, that's what we're solving for. Find speed. That's what the question says. Since we don't know the speed, we're going to leave that as r. Times. The last thing I need is my time. Do I know the time?
Yes.
What's the time in this case?
19 minutes, 30 seconds.
Can you say that again? What's the time?
19 minutes, 32 seconds. Oh,
19.32 seconds. So this is 19 seconds and then a little bit more. Okay, so 19.32 seconds. Now, the only thing I don't like about the way I started writing the equation down is I put a dot that's going to represent multiply. But the problem is time has a dot. So to me, this can look, to me that looks a little confusing. So what I would probably do instead is put that in parentheses. So now it doesn't look as confusing. All right. So let's see if we can figure out what case this is. Anyone think they know if that equation is case 1, 2, or 3? Yeah? Yeah, case 3. It's just like the one you did with 8.5. I forget where we did it, but it was like 8.5 times x or something. Yeah, right here. We have a decimal attached to the letter. So, Sean, since you said it was case 3, how am I going to get r by itself?
Divide 19.32 on each side.
Divide 19.32 on both sides. And when I divide both sides by 19.32, Liv, what's 19.32 divided by 19.32? 1. That's why we did it, to cancel it out. So now we have r equals, and now we're going to need a calculator. So let's type that in. 200 meters divided by 19.32 seconds. That's about 10.35. Okay, if we round it. 10.35 meters per second. That's his speed. So for us, we're familiar more with like miles per hour. We're not really as familiar with meters per second. So just to give you an idea of how fast that is, let's convert it and see. 10.35 meters per second to miles per hour. People see how fast he was running on average? Over 23 miles an hour. You think you could run 23 miles an hour? And that's not even his fastest speed. That's his average. So at his fastest, maybe he was going close to 30 miles an hour. That is pretty fast. All right, so that finishes up section 1.1. Okay, couple reminders for homework. You guys have 1.1 part 2. Is anybody unsure where to find it? Okay. Again, if you want to get a binder, that's fine. I'm going to try to remember to start hole punching them, so that way if you want to put them in a 3-ring binder, you can. But I would have something to organize your notes. Otherwise, if you just keep throwing them in your bag, you're probably going to lose them. We don't have to do that. I had you guys do edge elastic at the beginning of class. I made sure you all could get in there. First test is this Friday. I will be after school tomorrow if anybody needs extra help. And don't forget, if you need anything because you missed it from class, you can go to my website. And this video from today will be online probably in about 10 minutes. Any questions on that? All right.